when two projectiles are projected, is it possible to know whether they will collide in midair or will they pass close to one another, and is it possible to find at what time do they get as close as possible and what is the least distance between them when they are the closest? So such problems are related to understanding relative motion between projectiles. Hello and welcome. Supreet here, and today we will be discussing about relative motion between projectiles. Let's begin. So here we have a coordinate system. So that is the y-axis, and we also have an x-axis. Let's say that this is an x-axis here for our discussion, and we have two projectiles. Let's say a projectile that's thrown here with an initial velocity u1, and there is another projectile which is thrown with another velocity u2. Let's say the first projectile makes an angle theta1 with the horizontal, and the second projectile makes an angle theta2 with the horizontal. Now, if you write down what are the x and y components of these projectiles, u1x would become u cos theta and u cos theta1, and u1y would be the initial velocity of the first projectile along the y-axis, and it is u1 sine theta1. Maybe you should call that u1. And here we have initial velocity of the second projectile along the x-axis being u2 sine u2 cos theta2, and initial velocity of the second projectile along the y-axis would become u2 sine theta2. So these are the initial velocities. If you just look at it, the acceleration of the first projectile is ax, and that's anyway 0, and it's the same for both of them. The acceleration in the horizontal is certainly 0, and you also can think about the acceleration along the y-axis. Acceleration along the y-axis is in the direction of negative y, and it's minus g, because it's in the direction of negative y, it's minus g. Having shared that with you, if you were to talk about the initial velocity of the projectile, first projectile, as seen by the second projectile along the x direction, then you would have to write it as u1x minus u2x, my friends, which is going to be the u1 cos theta1 minus u2 cos theta2. And similarly, if you wrote the initial velocity of the first projectile as seen by the second projectile along the y-axis, it is initial velocity along y for the first projectile minus initial velocity of the second along the y direction. So certainly this is going to be u2 sine theta1 minus u2 sine theta2. u2 sine theta2. This is the initial velocity of the first projectile as seen by the second projectile along the y direction. But what is more interesting is the acceleration of the first projectile with respect to the second projectile. Of course, it's all along the y-axis, because anyway there are no accelerations along the x direction. So if you just look at what it is along the y direction, it's going to be acceleration of 1 along y minus acceleration of 2 along y. Both of them are minus g. Minus of minus will become plus, and the acceleration will be 0. So the second projectile essentially will see the first projectile moving in a straight line, and it's certainly not accelerating because both of them are being accelerated at the same rate. So the two projectiles will see each other traveling in straight lines. Now that is absolutely fascinating. You use that concept and you will be able to solve problems. Let's begin with the first one. A particle A is projected with an initial velocity of 60 meters per second at an angle of 30 degrees to the horizontal. At the same time, a second particle B is projected in opposite direction with an initial speed of 50 meters per second from a point at a distance of 100 meters from A. If the particles collide in air, find the angle of projection of projectile B. We got to find alpha, my friends. Well, It's quite simple to understand. Let's think about it. We have to first find the angle of projection of B. If the two projectiles are colliding in air, because the question says that the two projectiles will collide in air. If the two projectiles will collide in air, then they must be traveling exactly at the same height at all times. Isn't it so? If that is the case, because they are being projected from the same horizontal level, they must find themselves exactly at the same horizontal height if they have to collide with one another. So when that is the situation, you can now say that the initial velocity of the first projectile along the y-axis, which is uay, should be equal to initial velocity of projectile B along the y-axis. If this condition is satisfied, then they are both traveling at the same speed in the upward direction. Of course, they are advancing towards each other, but because they are being thrown in the upward direction with the same speed, they will be at the same height at all times. Of course, they will eventually get closer and they will collide. That's exactly what the question says. We have looked in the previous slide how to do the projectile's initial velocity components along the y direction. Let's do that. Initial velocity of A sine theta, maybe I should call this angle theta, that should be equal to initial velocity of B sine alpha, and we got to find alpha. We have to find alpha. UA, dear friends, is 60 sine theta is 30 degree. That's equal to UB, that is 50 sine alpha, right? So we have sine 30 being 1 by 2, and this will become 30 equal to 50 sine alpha. Alpha would become sine inverse of 3 divided by 5. Sine inverse of 3 by 5 is 37 degree, right? Sine inverse of 3 by 5 is 37 degree. I think we've answered the first question. The angle of projection of the projectile is. So the angle of projection of the second projectile, B projectile, is 37 degree. Going further, the time at which the collision will take place. We have to calculate the time at which the collision takes place. Let us understand this. If you talk about the displacement of A as seen by B, because totally together it's supposed to be 100, but when you write the displacement of A as seen by B, B will assume itself to be at rest, and it will assume that all the motion is done by A. That's what is relative velocity. So the total displacement of A as seen by B, if B is at rest, it will see A coming towards it. That direction is positive x direction. So you can substitute that as plus 100, my friends. That's plus 100 meter, right? And initial velocity of A as seen by B can be figured out, and that too only along the x direction. We will talk about only along the x direction because we want to find the time for which in which they would meet one another, because they're colliding. The question says they're colliding. So we have initial velocity of A in the x direction minus initial velocity of B in the x direction. So how do you work this out? Initial velocity of A is 60 cos 30 degree minus of minus would become plus, because the component of velocity for B is in negative x direction. So minus of minus would become plus 50. You have 50 cos 37 degree, because we've just calculated that 37 degree. So what do we have? Cos 30, my friends, is root 3 divided by 2. So we have 30 root 3 here, and there we have cos 37 degree. Cos 37 degree being 4 by 5, and this will become 10. The answer is going to be 10 into 3 root 3 plus 4. That's the speed with which B will see A moving in the x direction. That's how you analyze that. And now we have to find time. I just told you that they are not accelerating along the x direction. So the acceleration of A as seen by B in the x direction is anyway 0, we will be finding time. Now time would simply be total displacement as seen by B divided by total velocity, relative velocity of A as seen by B in the x direction. So what do we have? We have 100 divided by 10 into 3 root 3 plus 4. We have zeros getting cancelled. So the time it takes for them to catch up in air would be 10 divided by 3 root 3 plus 4 second. That's the time they are going to take. That's as simple as that. Otherwise, if you do not know the concept of relative velocity, it's going to become really tough for you to handle questions like these. Going further, the distance of P from A where collision occurs. So A is going to go this way, B is going to go this way. They're going to collide somewhere mid-air there. What is the coordinate from A? That means if you take A to be the origin, at what coordinates does the collision take place? That's the question. Dear friends, it's very simple. We know that the time here is about 1.09 seconds, and in 1.09 seconds, the collision is going to take place. You have these equations with you, and the equations are S along the x-axis for A. The displacement of A along the x-axis is equal to initial velocity of A along the x-axis multiplied by t plus half into acceleration of A along the x-axis, which is 0, multiplied by t square. Ax is 0, Ax is 0, so it's only uax into t, and you know how to do that. I think we've already written the value here. And similarly, you can find the displacement of A along the y direction using a similar equation. You will simply write ua along y multiplied by t plus half ay into t square. When you do this, the displacement of A along x, the displacement of A along y would simply be the coordinates, at which the collision takes place. So because this, dear friends, is SAX and that is SAY. So you have these coordinates and you will be able to find the place at which distance of P. Of course, once you know the coordinates, it's very, very easy. It's root of SAX square and a root of SAY square. In case you are able to do this, comment with a thumbs up sign in the comments. In case if you need more practice, you can send me an email. My email is right on the video for you. So if you will have to sit and practice for all of these to happen in the exam, right? So with this understanding, we will hop to the next question, hoping that you will continue it from here. Write your answer in the comments, by the way. Let's continue. The second question says, in the figure shown, the two projectiles are fired simultaneously. The minimum distance between them during their flight is. That's the question. Let's answer that question. Let me call the first projectile A, my friends, and the second projectile B. We got to find the minimum distance between them. For that, let me write the initial velocity of A in Cartesian form. How do you do that? You would write it as 20 root 3 cos 60 degree I cap plus, right, 20 root 3 sine 60 degree j cap. Okay, so what does the initial velocity of A in vector form look like? Cos 60, my friends, is 1 by 2, so it will become 10 root 3 I cap plus sine 60 is root 3 by 2, so we will have 30 j cap, because root 3 into root 3 would be 3 and 20 by 2 is 10, 10 into 3 would be 30 j cap meter per second. I have expressed the initial velocity of projectile A in vector form. Let us do the initial velocity of projectile B in vector form. Similarly, it would be, you see, UB cos 30 degree in negative x direction, because do you see this projectile has a component of initial velocity in the negative x direction, and that's why I write minus ub cos 30 degree, and then I have plus 20 sine 30 degree j cap. Okay, so we have initial velocity of b, the initial velocity of b being ub, my friends, is 20. So maybe I'll just substitute that. Minus 20 cos 30 is again root 3 divided by 2 I cap, plus 20 sine 30 is 1 by 2 j cap, right? So ones are tens are, the initial velocity along b would become equal to minus 10 root 3 I cap plus 10 j cap. That's all you have. Now what I'd like to do is find the initial velocity of A as seen by B. How do you do that? Initial velocity of A minus initial velocity of B. We will have to substitute it in here. What is initial velocity of A? Initial velocity of A is 10 root 3 I cap plus 30 j cap minus of minus would become plus 10 root 3 I cap minus 10 j cap. Let us simplify this further. That's the initial velocity of A as seen by B. We have 10 root 3 and 10 root 3 becoming 20 root 3, my friends, I cap, and then we have plus 20 j cap meter per second. So this is the velocity of A as seen by B, and if you imagine this whole event occurring, let's assume that the line I have drawn, the dotted line that I have drawn, marks their initial point, marks their initial positions. Let's say we have A here and B here. What we have computed here is the initial velocity of A as seen by B. So B is seeing A moving with this velocity, and as I told you in the beginning, the two projectiles do not have relative accelerations. That means relative acceleration is 0. That means we will see A going in a straight line. So how is this going? If you just look at this vector is in the first quadrant. If it's in the first quadrant, then the vector can be drawn this way. Let me draw the vector like that. Okay, the vector has now been drawn like this. When that is the case, you can call this velocity UAB, right? You can call this velocity UAB, and I want to know what is the angle it makes. How do you do that? Very simple. Just drop a perpendicular. I'd also like to extend this A in that direction. For some reason, I'll tell you in a while. Well, if you look at the components of this velocity, if you just look at the components of this velocity, along the y direction, it's 20. This is 20. And along the x direction, it's 20 root 3, right? So it's quite simple to see what theta is. Theta is opposite divided by tan theta is opposite divided by adjacent, which is 20 divided by 20 root 3, which is 1 by root 3. Tan inverse of 1 by root 3 is 30 degree. So we now know that the angle theta is 30 degree. Once you know that, if you want to find the closest distance between them, then the closest would be a perpendicular drawn to its trajectory, somewhere here. A perpendicular drawn to its trajectory. The initial distance between them, my friends, was 20 root 3 meter. The initial distance between them was 20 root 3 meter, and that's the hypotenuse of this right angle triangle. You're talking about the opposite side because this is theta. So this is going to be 20 root 3 multiplied by sine 30 degree. Sine 30 degree, my friends, is 1 by 2. When it's 1 by 2, the answer you would get is 10 root 3 meter, and 10 root 3 meter is option B. It's so fascinating that you are now able to find what is the closest that these two projectiles will get with respect to one another, and it's a fascinating thing if you are able to do by yourself. Such questions keep appearing in different competitive exams like JEE and Neet. I want you to practice them well. If you need a worksheet, send me a mail on supreetcr@gmail.com right on your screen, and I shall help you. we are together in this. Let's crack the JE exam and the other competitive exam you're intending to write, with all with all possible effort that we can put. Thank you so much.